Hello everyone. Thank you very much for coming. We'll be talking today about the switches and everything that is connected to them, like a bit of sarcasm, you know. And I will use some slides from the CompTIA course, but not a lot of them, so you won't get tired. I do hope so. Let's start from the bit of history. Yeah. When we're talking about the switching, about everything that is connected to the network, everything that network is all about, we should remember one figure. That is 1984. This is a very prominent figure. Not because some prominent English writer wrote some book with this name, not at all. But this is the year when the very good and very useful device has appeared and was invented. This device was called, I will show it to you, the bridge. That is 19, it is 19, yeah, 84. Okay, I'm so sorry for my English and for my writing. There are two things that I need to improve more and more and more and more. Okay, so in 1984, the bridge was invented. This changed everything, really, because right now, not right now, but from this year on, we had an opportunity to divide the broadcast domains, to get rid of the overall broadcast domain. That was really a disaster in the networks which were built using the hubs. What was the hub? The hub was it was more mechanical than the logical. You know, it is a strictly electrical device that multiplied the frames, multiply the signals inside the network. So if you have some computers connected to it, then all the computers could either listen or transmit. So one computer, one endpoint could either listen or transmit. It was really a problem. So whenever one started the transmission, we got the collision, and when we got to collision, everything stopped, and no one can communicate. No one could communicate. I'm sorry, and so this was the main problem of the networks. The collisions were like a disaster, really. We still sometimes experience it especially when we have the half duplex networks, but from this year, from 1984, like I said, it became possible to build extensive networks. Really, when you have a hub or you have several hubs, and if you have more than 10 or 12 or 20 devices on the network, that I think 50 was the absolute maximum, then the effectiveness of the network is very low. You get collision all the time, you get collisions all the way through, and no one can communicate really. So the more devices, the more collision you have. And the more devices, the less is the efficiency of the network, the less is the throughput, the less is the available throughput. So it was not really a way to build high-end, extensive networks and to make intellectual networks and to use the networks as the business leverage, like we do it today. So the bridges, they provided the opportunity to divide the collision domains and still keep the network as one whole. So now we can build the lens, thanks God, and thanks to the company which is called DEC, Digital Electric Growing Corporation. But it is not the only gift from this company to us. Next year, the 1985. Yeah, 1985. If we had some extensive audience right here, I would rather ask, and I usually ask my students what happened this year, and sometimes I get the answer, but most students, they don't know it. Still, it is a very important date. On 1985, the protocol, which is called Spanning Tree Protocol, was invented and patented. And what is more important nowadays, it was invented by a female human. So like woman power and so on began from this state. Her name was Radia Perlman, and she was that time she was just a graduate from the MIT. And the word just is not applicable to MIT, but still, she has just graduated, and she was employed by DEC, and then these two great minds, I mean the corporation and the Radia Perlman, they united, and she invented the STP. And thus we could get rid of the loops in the switching or in the bridging, because if you have some if you ever met the STP terminology, you know that they don't call the switches switches, they call them bridges, because at that time there were no switches. The switches as they are now, so what do I mean by switches themselves? They appeared or were invented around 1980, 1988. Another prominent year, I'm sorry, another prominent year in the history of the IT, 1988. It was arguably one of two companies. They both pretend that they were the first. The first company was named Kalpana. It's the name of the wife of one of the co-founders, so she was of Indian origin, but yeah, it was a really beautiful name. And another was Crescendo Communications. Both companies were later acquired by Cisco, and that empowered this company, which we all respect, to become a leader on this switching market. What did these two companies do? They did one simple thing. They had like the code mark for bridges like that. So they united many bridges in one body. Yeah. So here they were united by the motherboard and the processor, and from here, from this side, we had the endpoints connected to them. This was an ingenious architecture, really ingenious, and it was a great idea, really. Why no one invented that before them, I don't know, but it took around 4 years to get to practice and to get to the business. Okay, so we get what we are presently called the switch. Usually, the code sign for switch is something like this.
I'm so sorry. We don't see presentation.
You know, oh, I'm too sorry so much. Here we are. Here we go.
Yes.
Yeah. So the guys took some bridges. Yeah. Here we are. Yeah, and then put it in the same body. And so we have the endpoints, like computers here. What did this device about was to do? Now we, from this time on, we could and we can right now to divide the not to divide, to limit the collision domain to one report. So if we had before the collision domain on several ports, then now we have it on just one port. Yeah, and so we got rid of the collisions. Now we can transmit and receive the information freely. Yeah, not caring about the transmit, not caring about the collisions. But anyway, the switch is still a broadcast domain. Broadcast is a very peculiar issue in the networking, as you know, or if you have talked to engineers and so on. So we can't really operate without the broadcasts, as the simple, the basic protocols of the Ethernet, like ARP, like DHCP, like so on and so forth. They are working using the broadcast. So it is sometimes very important to send some packet or some frame to everyone on the network. Yep. And switches, they are very obedient things. So if you tell them, okay, send it to everyone, they actually send it to everyone. So like no disobedience meant in the very beginning. But it creates a strain on the network. It creates a very high load on the network because the more devices you have, the more broadcast frames and the more broadcast packets you distribute. By the way, here how the switch is working. Very basic things. And so with the broadcast domains limited to switching, we had to wait to another 10 years, so that in 1998, the people invented VLANs, virtual local area networks. And this revolutionized the switching to the extent that now it is the indisputable part of the networks. And we can't go anywhere without the switching. We use it everywhere, and now they are solid, they are secure means of communication, and so they are the imminent part of the networks. Okay, let me switch to some other like instrument, like other tool. That is, here we are. Oops. Oh, here we are. No. Can't find the application, sorry. Oh, here we go. Yeah, here we go. So what can we say about the switches? About switching? There are a lot of classifications, a lot of methods of classification for the switch. But still, we should use, I think the most, not that we should use or must use, but the most widespread classifications are like that. The first is the managed versus the unmanaged switches. What they are is understandable from the very names of them, of these categories. The unmanaged switches they are not allowed to go inside them. They're not allowed any configuration from the point of view of the user or from the administrator. So they act like they are from the factory. And the operating system is programmed in a very certain way, I may say, and so they usually they are also called the dump switches. So they're not really smart guys. Just switching, just sending the frames, but they still have the MAC address tables, which are, but they can be managed. You can do anything with them. Still, they're not really dumb devices. If we have, for example, the switches from Cisco CB series, CB100 series, I'm sorry for mentioning some vendors here, but this is what I know. This is the vendor I know best of all of them, and the vendor that still produces a very good unmanaged switches. Really. So if we take this line, the CB100, then they are dumb. They are dumb. They can't do anything. They can't do policies. They can't do access list. They cannot do any routing. They can do anything that is used in the modern switches. But still, they can do something like loopback detection and loopback management. That means, okay, they don't have STP. They don't have STP, but they have loopback detection. And if the user wants to make any loops, then it will detect it. One port will be excluded from the communication, so I will shut down, disabled, and so on. Then another feature of them is the QoS. So they can set some priorities to the traffic that they are passing. They can't do any VLANs. That is very big very big shortcoming, of course. But still, they can do a lot of things that are convenient, and they are making them a very good, reliable tool for the small networks, home networks, small offices networks, small branch networks. Ideal solution for everything of them. And the one more feature that still makes them going is the PoE feature. Many of them have PoE, many of them can provide the power to the devices, and that makes them very useful in the small networks. The managed switches, on the other hand, they can be managed, so they can be administered. So you can program, configure them and program them. So when we're making the configuration, you can use such features as VLANs, the policies, the QoS, especially the QoS. The traffic prioritization is very important in our day nowadays, and we'll talk about it all the time today when we're talking about the switching. And a lot of, and of course, routing. The routing is an indispensable feature right now, especially in the distribution layer. Maybe it is not really important. Like, it is an arguable question, really, whether the routing is important or is it useful on the access layer, because when we are talking about the SDNs, the routing starts from the very access, from the very first port. But in classical networks, in the hierarchical model, which has three layers like access, distribution, and the core layer, the routing is started to be applied on the distribution layer, not on access. Still, we have it, and so on and so forth. So the managed switches are what we are talking about is and the breakdown of the switches today is like, I mean, in corporate environment, like 90%, 90+% versus 10-%. Yes, it is that big because you can't use the unmanaged switches everywhere, but only in a very specific environments and very specific deployments. You know, I do like that. Another classification is the fixed versus modular switches. Fixed versus modular form factors, in fact. So when we're talking about the fixed switches, we have one body. Usually it is one rack unit high, and it has everything inside. The central processor unit, the motherboard, the ports, and the connecting thing, I mean the connected circuits, the ASICs, which is a very important element of the switching now, because most parts of the traffic is forgot a simple words in English. I'm sorry, it's not my mother tongue. Is processed on these special microcircuits, which is called ASIC, application specific integration circuit scheme. Integration, circuit, and the most part of the traffic is processed via them, not via the central processing unit. It is for policies, it is for access control lists, it is for everything else, but the ASICs are the people who do the main job here. These switches are cheap, rather cheap, if compared to the modular ones, but they are like they are fixed, so you can change the actual physical configuration of them. So if you have, for example, 28 gigabit ports, 28 here, where we are here, 28 1 gig ports, then you can do anything without it. When you can do anything with it, and it stays for 28 1 gig ports. When the time comes and you are no more satisfied with these 28 1 gig ports, you want, for example, 28 10 gig ports or 28 40 gigabit ports, you can do anything with that. You should either sell the switch or either otherwise get rid of it and buy the new one. So they're not really convenient in this respect. But actually, when we're talking about modular switches, here we go. So we have 4 main elements. The first is the chassis. The chassis is actually a frame that allows us to install anything we want. That is why we call it a modular switch. We are working in modules. Another very important part is 2 cards that are called the supervisor. The supervisors are usually we use 2 of them for one the same chassis for the redundancy purposes. Redundancy. For the it's always better to have 2, not 1. So we have 2 supervisors, and then we have of course the modular power supplies here. Of course, they are interchangeable. They are changeable in the hot swap mode. Everything is made for the redundancy, and everything is made for the efficiency. And then we have very special, the 4th the last but not least important element, these are the line cards. And these line cards are actually the set of ports that you can, set of interfaces that you can use. So all the traffic processing is done on the supervisor. And the policy and the central processing units, usually there are several of them, and all the brains are located on these two cards. And then we have the line cards with whatever set of actual ports you want. So you want 24 10 gigabit ports, you just buy the card and you set there, you have no problems. You want 4 100 gig ports, no problem. You just you buy 2 of them for redundancy, of course, and then you put it there. You install it there and you're working. You don't want to use the 100 gig ports on these very premises, and you want to exchange it to 96, for example, ports of 1 gig. There's actually no problem. So you may change the cards, you may buy new ones, you may sort them in whatever combination you want. This is what the modular switches are for. They are of course, they are more expensive than the fixed ones, but they are more expensive in terms of units, not in terms of ports. If you want really high port density, then the modular switch is your form factor of choice. Yeah. Another feature of the modular switch is that you can flexibly approach the number of ports you need. For example, you need just one card here, but you know that the organization or your client's organization or your own organization will expand really fast in, for example, the nearest 3 or 4 years. So you invest in one chassis, yeah, you invest in the supervisors, and then you can buy 1 or 2 line cards to connect the existing users, and then after that you don't have to buy new switches like you would have to do with the fixed ones. You just need to buy the line cards, and they are, in this respect, they're cheaper per port than the fixed switches. Yeah. So this is the flexibility and the redundancy that are the main factors for choosing the modular switches. Yeah. So these are the main types of the switches that we're using right now. So let's talk about the enterprise switching that is used right now nowadays and that is developing versus the data center switching, and how these two kingdoms can relate to each other and correlate to each other. The switches originally they were invented, they were used in the corporate environment. Now we are the first, if you remember, the first LANs, the first networks were called the campus networks. Yeah, the campus. Why? Because they were invented for the universities. They were used for the universities and for university campuses. You've got several buildings. They are equipped with with the equipment of the several vendors, different computers, different switches, different network devices, different everything. As the law school on the campus can have one vendor, the economics school may have another vendor, so on. It is always a mix. It's always a mix and a very different mix. Not homogeneous in any respect. So we had to deal with this, and all the science came from the campus. I mean the network science. After that, the main impact of the land building, it came from the enterprise from the business. So VLANs were invented by the request of the business. Many technologies were invented by the request of business. So the business networks, they became the center of the competence in the with respect to networks. And so that is why we called now that is why we call the networks mainly the enterprise networks, as the most parts of the requests and most parts of the brains are working there in the enterprise segment. So as I said, initially the switching was invented for the campus networks and for the enterprise networks. But now, in 2000s, into 20s and 2010s, especially 2010s, we had we were witnessing the appearance of another industry, of IT industry, which is the data centers. Data centers. Initially, they were just a bunch of servers connected with some switches. The enterprise solutions were quite enough, and so there was nothing to talk about, really. There was no great an issue about the data centers. Just a bunch of servers. But then we've had the storage. And this also gave another impact for the switching, as when you are using a large amount of storage, as you have this special storage device, you can't use Ethernet. Ethernet, I'm sorry, is the main technology used for the enterprise. Ethernet, I'm sorry. Yep, my handwriting is even worse than my English, so I have to say sorry for that, but I'm working on it. Yeah, still. So the Ethernet, by the nature, is the protocol that allows for some latency, and it allows for the losses. So the loss, the packet loss, and the loss, and the latency, they are immanent. So they are encrusted in the very structure of the Ethernet. So you can't send anything without first ARPing the device, for example. And the ARP is the broadcast. So when you when your devices they are processing the broadcast, they got latencies, so they got busy on the network, and some packets get lost when they're going through the routers and through the L3 switches. As I said, it is imminent. But in the storage area, you can't do that, because you want to get everything from the server, all the information that the server wants to store. You need to make sure it is stored, and you need to know where it's stored, so that when you want it back, or when you want to download it into, I don't know, the memory, or you want to get access to this bit of data, you should do it with the maximum speed, and you should know where it is, so you don't have time for the search or for the querying the network and so on. So the special storage area networks were invented. And with these storage array networks, basically the data center use two kinds of networks, the LAN and the SAN, and they should be working in the perfect unison, so that you have all the features that the data center is built for. In the SAN network, but how can we make them to work in the perfect unison, as they are naturally different? The SAN networks used the protocol which was called the FC, the fiber channel. The LAN network uses the Ethernet. How can we match them? So then the humanity had to invent one more thing. Yeah, these were these certain switches which were called the United. Not the United. Let me think about that. The not the uniform access. Yeah, they called them the United Port switches. They were the devices that could understand and could switch both the traffic from SAN and and the traffic from LAN. So the Cisco is called them the Nexus switches, and they are widely used in the data area networks. But what is also peculiar about the SAN network? The SAN network, this one, they are using something called the fabric. So all the switches are united into one entity. Yeah, so that any server can have an access to this entity, and then these switches collectively decide where to transfer traffic and where to switch the traffic. And the sorry, and the concept of the fabric. It was such appealing, and it was such attractive that it had no way but to migrate to the enterprise domain. So that is how the SDNs, software-defined networks, they appeared first in the data center domain, in the data center kingdom, and then they moved to the enterprise segment, and here they are thriving now, and here they are flourishing now. So what about the difference between the enterprise and data center networks, where the switches also are used very widely and very thoroughly. The main difference between them is probably the main architecture. As you see, and as you could remember, the first model that we are talking about in CCNA courses and any other networking courses is this hierarchical model of the network. So we've got, this is for enterprise of the campus networks and so on. The first layer of the network where the endpoints are connected is the access layer. Yeah. Another one is the distribution. And the last but not least one is the core layer. The devices are connected to the access layer, as I said, the computers, the telephones, the IP phones, and so on and so forth. So here we got the PoE, and so maybe some CCTV cameras, and so on. So the access layer, the main task of the access layer is to connect the devices, to provide them PoE, I mean to provide them power, and to provide them fast access to the network, and of course the basic connectivity and the basic security, so that you don't allow to the network the devices that are undesirable for our network. Only the allowed devices should be allowed on the network. Yeah. That is how the concept of zero trust appeared. You should not trust any device, but you should check the device, and you should make sure that it complies with all our security policies to let the device into our network altogether. So with the distribution layer, the main thing here is the routing between the VLANs, so routing among the LANs, the basic routing of the packets from the devices, and so the interconnection between the access switches for the sake of the redundancy, and the high availability. The core layer, it makes possible to unite several LANs, to unite several networks, especially in the campus environment or the enterprise environment, into one. Yeah. So that you don't, so you can, for example, connect another set of distribution switches here, and you can do it much easier than without the core layer. But it is like the technical issue. We're not talking about that today. We're talking about the switches. This is the general model that everyone knows, and so on and so forth. When applied to the data center, this model is a total failure. You can't do it in the data center. Why? I will explain why. Here we have the L2. Layer 2 of the OSI model, and the technologies are which are applied here are the pure layer 2, which means we have the spanning tree protocol here. The spanning tree protocol is famous for blocking the undesirable ports. You can, of course, you may be the very talented administrator, you can be a very qualified administrator, but still you can predict for the 100% which port the STP will block. It happens all the time. It really happens all the time. It is necessary to have this feature, and it is very in fact, it is a very useful feature of STP, because otherwise we would have the loops, we would have storms, we would have everything else, which is much worse. But still, when we're talking about the applications, when we're talking about the distributed applications, and when we're talking about the virtual machines that are moving between the servers, and so they're moving between the switches, this model, I mean the hierarchical model, is extremely rigid, it's extremely inflexible, and so especially with the STP. So there is a very high opportunity and very high probability that some application or some virtual machine can be nested to some port that will be blocked by spanning tree protocol. And you probably know, if you learned something like VMware technologies and so on, some vendors use the virtualized switches that are far below the, I don't know how to, far below the surface of the virtualization domain, and they still can cause the loops, and the STP will react to them, so we have total mess in our network. That is why the people came with another model that is called stem and leaf. So essentially, these are the switches to which the endpoint devices are connected in the data center. So what are the data center endpoint devices? They are servers. They are servers, they are virtual machines sometimes, but mainly it is the servers. So like this, S1, S2, S3, and so on. So they are connected to the switches. How can we connect these switches into something uniform, into something whole? Then we have the upper layer switching that are called the stems. So here we got leaves, and here we got stems. And thus this architecture is called the stem and leaf. The essence of it is that every leaf is connected to all the stems. But the stems themselves are only connected to leaves. We can do the fourth leaf here and the third stem here, and then we will have the architecture something like that. Yeah. So despite the complexity of this network, but it is really very simple, and it does one very good thing. The layer 3 technologies start from the very first uplink ports on every switch, from the very first uplink port. And here we got the L3 domain with the routing protocols doing their job, and doing their job really nicely, to be honest. So here we got the routing domain. Here, like, to be so in red it will be the route, definitely routing domain, and here we got on the L2. So in the second layer, in the layer 2, we got some switching, but we have a very low probability of the STP working here. And what is really more important, when we got the virtual machines that can be moved from one switch to another, as it is moved from one physical server to another. S3, for example, if the virtual machine is moved from S1, so server 1 to server 3, then it will also be moved to another switch. But we should do nothing, as we have one fabric. This is here the fabric appeared, and we use the special protocol which is called VXLAN for delivering the traffic, so that the endpoint devices, they don't really understand how the traffic moves, so they pretend still that they are in some LAN, and there are some very simple LAN. Okay, and what is more important in this topology and in this fabric is that you have the guaranteed one hop between the endpoints. So if we have the L3 starting here, the layer 3 starting here, even if the switch goes off, even if this switch is going off, then you still have the connection to any desired switch, to any desired server, and to any desired LAN. That was the very important feature of the DC networks, of the data center networks. After some time, this architecture, this idea of such a network, it had no chance but to move into the corporate market, and it did. So here we got the SDN, the software-defined networks. What it is right now? So today, it is a very widespread concept. Everyone does the SDNs. So Cisco does SDNs. Huawei does SDNs. Extreme Network does SDNs. Arista does SDNs. Everyone does SDNs. And this is also the idea behind the SDN is to make the network work as one switch for the endpoint devices. Yeah, but in this respect, we had to, I mean the humanity or some vendors and so on, the IT industry, we had to solve a lot of issues, to be honest, and they're not solved sometimes successfully, but everyone claims that their decision, their solution is the best. For example, this Cisco, the guys made something like that. So they get the edge points, the intermediate, no, the edge nodes, not edge one, but edge nodes, the intermediate nodes, and there's some controlling nodes. Control node, this is the edge node, and also some, how to say, body node. These are the switches. They can be switches, they can be routers, connected in whatever fashion you like, in any way. So what do they do, in fact? So here we got the fabric. And the fabric is working. From the very port, the endpoint is connected. Okay, I think that I've got some issues here. Sorry. Okay, there was no. I think there was some question. Let's say, okay. No, a very silent audience here. We got. So when the an endpoint is connected out here, and it wants to send the traffic to some other endpoint out here, how is it possible when we have L3 here? It is not possible without the controlling node and without the controlling server that orchestrates the whole network. If we have the simple network, the simple LAN, yeah, what are we doing here? The endpoint wants to send traffic to another endpoint on the another switch, connected to another switch. So what do? We are ARPing this very endpoint. We are in the same network, so we are ARPing this endpoint, this computer. We get the ARP reply, and so we that is how we know the MAC address of this device, of this endpoint. Yep. How can we do it here? As any MAC address will be lost on the L3 layer. This is how networks operate. So we have to ask the control node about where the device is. So we are intercepting the ARP here. And yes, the L3 doesn't allow the ARP, as it doesn't allow the broadcast things, the broadcast distribution. Right. So finally, we have got rid of the broadcast. Of course, we got some other problems, but we're trying to solve them. Now, if it is a kind of broadcast, or it is a kind of more multicast, the edge node, which is actually an L3 switch, it intercepts the package, it intercepts the frame, and asks the control node, do you know the MAC address of this IP address, of the endpoint with this IP address that is read from the ARP request? And the control node should answer, as it has all the endpoints registered on it when they are entered the network. So you've got the total database of MAC addresses and the IP addresses for the whole network. And this is the software solution for this problem. So we don't ask any endpoint, what is your address? We're asking specially defined a special designed device, what the address is. And so all the endpoints that are connected to the network, they are registering on this address. And so we know all their IP addresses, and we know all their MAC addresses. And we also know which endpoint, which edge node they are connected to. Yeah. Quite the same architecture is, this is what the Cisco did. This is what Cisco does. In fact, the solution is okay for me, but still, it is not without shortcomings. It is not without. It is not perfect. They're using two protocols: VXLAN and the Lisp. The Lisp protocols has its own issues, and then the issues can appear when they interconnect in when the Lisp is interacting with the VXLAN. Yeah, it is also an issue, and there can be problems with them. And of course, the time and the latency is larger for providing the interconnection and the interaction of two different protocols. Yeah, on the, I think, the L3 and L7 and so on. So this is the problem. Another architecture that can be used with SDN deployment is the EVPN. Which uses the guys use the BGP for the exchange of the MAC addresses between the switches, and there's some central device that is collecting the information about the MAC addresses and the IP addresses and so on and so forth, and then that can be that can distribute the traffic between the edge switches and between and also route it inside the network. This is more progressive, I think, solution, and many vendors implement, namely the solution like Huawei. They are not really liked in some Western Hemisphere, I know, but still they are very good in the solution. And I think the Arista is also implementing something like EVPN solutions in the SDNs. This is what we have today. Let us talk a little bit about the foreseeable future, about what we are doing in the switching. By we, I mean the whole IT industry, and what we can expect from the nearest future. Which technology we'll use in switching. The first one, of course, is the first trend that I should mention is the IoT. This is a really big thing, and it lasts for more than 5 years right now, for 5 years already. And we can't see the end to this technology as it is spreading. Everything is going connected, from the least things in your apartment and in your office to the very big, I don't know, machines, presses, lathes in the factories, and so on. So IoT is really a big thing, and we have a lot of digitize to the moment, and so when we have IoT, that means that the underlying switch technologies are PoE. That is definitely the case. Right now we have 3 standards for the PoE, and the last, which is ultra PoE, it provides up to 60 watts per port. 60 watts per port. I think this, I read somewhere that the R&D are now underway for making it 120 watts per port. It is really impressive figure, and it can power the more and more power demanding devices. Another thing with IoT, as I said, as it is used more and more in the industrial application, is the industrial switching. It will be developing. It will be selling better and better, and the more and more intellect will be coming to these switches, which right now they are quite simple. Of course, they are durable. They can be used in very harsh environments, but they still they will still be developing in terms of intellect. The AI, the second big thing, the AI, it also be used especially for security, for how to say, it will be used for recognizing the initial threats, the threats that were initially used at the layer 2 or layer 3, and still it will be coming in a really big way to the switching industry. The third one is the SDN. The SDN has many facets that are not discovered yet, and it still has a long way to go in the office environments, in industrial environments, in the, I don't know, there are no limits for this technology, especially in the like I may say old countries, the countries that are really dependent on IPv4. IPv4, you know that the developing countries, such as the guys in Africa, they're doing the exciting job on the introduction of IPv6. In India, they are world leaders in IPv6. In China, they are also introducing the IPv6 like crazy. But most of the old world, I mean the Europe, I mean the USA, they are so stuck to the IPv4 that the transition to the IPv6 is not really either not fully possible, or it costs really a lot of money. So as I see, and many analytics, not many analytics, many analysts share my point of view. Who am I? But I share the point of view of many analysts that IPv4 is here to stay for another 10 or 15 years. So the SDN solutions, they provide for the opportunity to stick to IPv4 without a compulsory transition to the IPv6. They are made for it. They give us much more things to stay on IPv4, and so it will stay here. For SDN, another switching feature for the SDN is that we will have the fusion of the something like WLC, which is wireless LAN controller, and the switch. The more and more such unified access that was introduced by Cisco and other vendors in this beginning of 2010s, but still now in 2020s it is coming back. also in a big way. I mean, VLC, not the VLS, wireless LAN controller, not the wireless LAN server. And it will be very important, especially with the IoT things, when a lot of things will be managed by means of a lot of things will connect to the network wirelessly, and they will be managed by means of wireless networks. These will be very important to move the controlling capabilities right to the switches and right to the front. The closer to the endpoint devices, the better. Also, when we're talking about the IoT and the SDN, then we will have the L3, L4 layers implemented. If you know, right now the L2 switch concept is almost obsolete. You will hardly find any pure L2 switches at any product line at any vendor. They are mostly the L2 either smart switches or L2 with some routing capability, because routing is very important right now, especially with the connection of the SDN. And we'll have purely L3 switches, probably, but they are still L4. Some of them is L4. Maybe the L4 capabilities like the ACLs, they will be, of course, appended and amended with the firewall capabilities, and I know several vendors that are already doing that. And the fourth thing we should talk about is the cloud. The cloud deployments are more and more popular, especially in the small businesses, especially medium businesses. You know that the cloud solutions like I know that the Ubiquity cloud solution is a great success. Even some hardware vendors like TP-Link, they also went to the cloud and they are quite successful. Cisco Meraki is a huge success. It was a huge success even before Cisco acquired Meraki, but it is still a very good example of the cloud solutions. The cloud solutions, when you got all the controlling all the controlling capability moved to the cloud, and you use these by subscriptions. You don't have to purchase any additional equipment. You can use everything through the cloud. They will be more and more popular. So if you consider starting the or moving to the network, you should really consider the cloud controlling opportunity, cloud management opportunity in your future deployment. And one more thing about the cloud that I want to say is the SDN controlling is also will be moved to cloud. Will be moving to cloud. Right now, you can even not purchase, but you can borrow some virtual machines with the cloud controlling opportunities from Amazon. I think there's Cisco gives you such opportunity for the SDN solution. You can borrow the solution from the Amazon cloud, lease the solution from Amazon cloud. The Meraki as well, a very good example. The some network security solutions is quite another way, but still the switching will be quite susceptible to this solution. Of course, the hardware switching will go nowhere, because we still have to connect the endpoints somewhere. We still make connection to all good copper or good fiber. We need to connect the devices wirelessly, but still the wireless access point should be connected to some switch. So the hardware switching will go nowhere, but it will require more and more intellectual property and more intellect nested in the device, not just connected to it, but nested in the device. And cost-wise, cost-wise. Another thing we should really talk about, and another thing we should factor into our future solution is the subscriptions. The subscriptions will be the main business driver for the networking companies, and we should get used to them as they will be will occupy a bigger and bigger part in our costs and in our spending to the networking equipment. Here we are with what I wanted to say today. Thank you very much for listening. Thank you very much for coming and for getting managing with my English. So if you have some questions, you are on the encouraged to ask them. Please.
Stanislav, thank you very much. It was very interesting.
So thank you very much. Thank you very much for such an opportunity. Okay, should I end the recording or you do it by yourself?